Greetings. My name is Stuart Sutton, and I'm an Associate Professor Emeritus at the University of Washington in Seattle. And I'm also the lead scientist with the Achievement Standards Network in the U.S., which I have been asked to talk to you about today. In my half hour or so that I'll be talking with you, I'll try and cover the following points about the ASN. I'll talk a little bit about what it is, its goals. It basically is data infrastructure that is intended to support 21st century teaching and learning through the deployment of linked data and semantic web technologies. I'll talk a little bit about how it's currently being used, and then spend some time talking about how does it work in terms of technology and in terms of processes. So what is it? The Achievement Standards Network, first of all, is a project of Jess & Co., a U.S. nonprofit dedicated to the education of youth. The ASN project itself has been funded for over a decade by the U.S. National Science Foundation as part of the National Science Digital Library Initiative in the U.S. The goal being primarily of the ASN to represent the learning outcomes, the achievement standards embodied in the curriculum documents of the 50 states in the U.S., plus the District of Columbia, in a machine-readable form so that the resources that were cataloged and put into the National Science Digital Library could be mapped to the standards, or the academic standards, the achievement standards that they addressed. We started out focused primarily on STEM, since it was the National Science Foundation, on STEM areas, science, technology, engineering, and mathematics, but quickly expanded across the curriculum. Today, the ASN is generously funded by the Bill and Melinda Gates Foundation. Now, terminology is a big problem in this area. As I've gone around the world talking about the ASN, and what we've done, it's become increasingly clear that we don't all mean the same things with the same terminology. So I need to define my terms very, very carefully. The Achievement Standards Network fits into the curricular fabric in basically providing a means for the description and use of authoritative statements of knowledge, skills, or habits of mind to be achieved, learning objectives, or to be assessed, learning outcomes. So the focus here is not on the whole curricular structures, but on the achievement standards themselves. Now, achievement standards take many, many forms across the United States and clearly around the world. Sometimes those statements, achievement standard statements, are statements of what a teacher should do. For example, pupils should be taught to ask questions. In other words, this is what the teacher needs to teach students. Sometimes they are statements of what students should know or should be able to do. If we look at the new U.S. Common Core State Standards, you find things like estimate lengths using units of inches, feet, centimeters, and meters. In other words, things that the student should know. So they take many, many forms, and they have even more names. The labels we attach I have not found to be consistent anywhere on the planet. Very, very diverse. These achievement standards that I just defined, you will find in the U.S. called achievement standards, academic standards. You'll find them in other places called things like core objectives. I think that's what they are here in the Netherlands. You'll find them called learning objectives, learning outcomes. You'll find them called benchmarks. You'll find them called competencies in new work out of the Bill and Melinda Gates Foundation. You'll call them competencies. Just many, many, many different names. They all mean, functionally for us, in terms of the Achievement Standards Network, the same thing. They are authoritative statements, in essence, of what students should know or be able to do. So, what is the ASN? The ASN is two things. First, it is a metadata framework. It is a lightweight, flexible, and powerful model and a set of best practices for describing and relating achievement standards to other achievement standards, forming curricular maps and so forth. Relating achievement standards to learning resources. Relating achievement standards to learners and learners to achievement standards, etc. So it's a means of describing and relating. In the US, it is also, however, a repository. So there's a framework, guiding description, and then there is a repository in the US called the ASN US, and it contains all of the achievement standards documents across the history of the standards movement in the U.S. So there are a lot of them. Some of them deprecated. The active ones, new ones are all there. Currently, there are over 1,000 of these achievement standards documents containing sets of achievement standards from the 50 states, District of Columbia, and various other sources. The ASN then breaks those down into individual descriptions of statements, individual achievement standard statements. And there are over 370,000 of those statements in the repository. And then if we look at the data level, there are over 4.5 million data points in describing the achievement standards in the US. We all know, or we took as our central assumption, that the achievement standards were central to any data management of the learning environment. We educate for a purpose, and achievement standards express those purposes in a narrative form by curriculum designers, in a form that is meaningful to humans. And achievement standards are inherent in the very definition of a learning resource and a learning activity. It is the fact that there is an educational purpose that turns a resource into a learning resource and an activity into a learning activity. And achievement standards, when taken from that narrative form and put into a machine-readable data form, provide a very powerful means for the discovery of learning resources, aligning what is taught with what is assessed, tracking what has been learned in meaningful ways, in things like transcripts, customizing learning to individual student needs, the massive data problems inherent in customized education, and then developing and maintaining longitudinal data on student achievement. Plays a role in all of those. In essence, it is a means when we have machine addressable forms of these achievement standards, plays a critical role in the tight coupling of what we expect students to learn, how they learn it through learning resources, and how they are assessed. A tight coupling is possible. At a machine level, that is possible. And once we're able to uniquely describe and identify all of these achievement standards, we can then begin to map them. We can map, for example, achievement standards in the US to achievement standards in Europe. And if we have learning resources and assessment resources mapped to those standards, we can infer mappings to enhance retrieval of useful resources. So, a fast trip through the ASN US to give you a sense of what it is. If you go to the ASN and browse the achievement standards, and you can do that, there's a URL in the last slides of this presentation. You can go there and freely browse them. You will find a list in the browse menu of all of the jurisdictions, in other words, the authoring jurisdictions of standards documents in the United States. And the states, District of Columbia, professional organizations, commercial companies, and so forth that have achievement standards. So I've blown up here the the previous cell to give you a sense of what is there in terms of the kinds of achievement standards. The first circle in red is the state of Alabama. If you were to click on Alabama, you would be presented with a list of all of the standards documents published by Alabama over time. And if you then clicked on one of those documents, you would be dropped into the achievement standards themselves. So Alabama is a U.S. state and territory, as it says over in the jurisdictional class. The second one is the American Association for the Advancement of Science, AAAS, which is an organization in the United States, a professional organization that promulgates achievement standards. The benchmarks for science literacy is a prominent source of literacy standards in the U.S. The third one down is Cisco. Cisco. Yes, that's correct. The networking company. Cisco operates the Cisco Networking Academy with 900,000 students globally, and also provides certification. So the achievement standards that make up a certification program, Cisco uses the ASN in order to guide a mapping of all of its educational programs globally at the level of learning outcomes, the level of achievement standards. And then we see the bottom one there is the new U.S. Common Core state standards, which stem from an organization, from the state's governors. Again, the U.S.'s first attempt at something that looks like a national curriculum, even though it is not one. So in the ASN repository, we have achievement standards for all of the states and territories, professional organizations, and corporate bodies that step forward and want to begin to express their learning outcomes, their achievement standards in machine addressable form. Let's take a look at one. I have clicked on Common Core State Standards in the previous menu, and it brings up the two achievement standards documents currently published by CCSS. Standards for mathematics. And if I click on standards of mathematics, I will then be able to view the standards, the achievement standards for mathematics in the Common Core. And what I've done on the left is expand the full listing, and you can scroll up and down the full listing of all of the achievement standards that are within the Common Core for math. And I've highlighted one, add and subtract within 20, demonstrating fluency for addition and subtraction, etc. And when I click it, on the right side, I see all of the information around that one single achievement statement. It is a full description of that one statement. It's these descriptions that there are over 370,000 in the U.S. repository of state standards. So each of these descriptions exists. Each is uniquely identified with a URI that looks like a URL there at the top in blue, and can be clicked and traversed and would function in a web environment exactly like a linked document. So each node is fully described. Underneath that human readable display, the data in the ASN is in what is called RDF, Resource Description Framework, which is W3C's language for data on the web, for describing and linking data. So the ASN is fairly advanced at the data level in that it uses the Resource Description Framework, which, as I said, is W3C's standard way to describe data about things, standard way to make that data available on the open web, and a standard way to link data to data and to merge related data. This is a big emerging area. There's a lot of activity around linked data and using RDF, and I've put here part of the cloud that we see of data that's becoming available on the web. A lot of government data, U.S. Census data, DBpedia, which is the data underpinnings, the data representations of what's in Wikipedia, and so forth. And just so you know that it's absolutely real, last week, OCLC, the largest bibliographic utility in the world, published all 26 million of its bibliographic records for 72,000 libraries in 170 countries in RDF on the open web, so they can be linked to and discovered through the browser. So how is this data being used? We've created these representations. How's it being used? There are two ways. One is in one category of way is in information retrieval, enhanced retrieval, being able to find learning resources that assist a teacher or a learner in achieving a specific standard, a specific learning objective. And the second form is data management of that. And I'll give you some examples here of both. ThinkFinity is a very large repository of consortium of partners in the U.S., including the Smithsonian National Museum and ArtsEdge and Verizon Foundation resources and so forth. All of those resources have been cataloged to, have been mapped to state standards for which they are useful. Teach Engineering in the U.S., a pathway in the National Science Digital Library, has all of its resources mapped to state standards using ASN framework. And you'll notice, for example, each row is an educational resource, and you'll notice the fourth column over is EDU standards, educational standards, and there are the Colorado standards. But if I'm a teacher looking at a resource description, and I am not from Colorado, I'm from Arkansas, I can pick Arkansas from a drop-down list and be presented with the standards in Arkansas, the learning outcomes, the learning objectives in Arkansas that this resource meets. WGBH Boston, the largest public television public television network in the U.S., has all of its resources mapped to the ASN, state standards in the ASN. Michigan eLibrary, the state's library for educational resources, also maps to the ASN. But here we see it going in the other way. Instead of having a resource and finding out what it has been mapped to, we have the Michigan standards actually presented to the teacher here primarily, who, when they find the statement, the achievement standard statement of interest, if there is the little icon that I have there circled in red, if they click on that, they will be presented with resources that meet that Michigan achievement standard. So that's an information retrieval kinds of context. Another is in the learning management system context, and here we see Desire to Learn, an innovative learning technology system, I believe, out of Canada, and they use ASN competencies for the states in their e-portfolio and student assessment mechanisms. So here we see an activity that a teacher has created within Desire to Learn. That activity in the top box has been correlated or mapped to a state standard, highlighted there in blue. And then the teacher can create that activity, line it to a state standard, and then also be able to assess individual students, which is lower box, assess individual students against that particular activity and the standards that activity met or helped achieve. Students also can keep track of their own learning competencies. They can isolate specific competencies that they set out to achieve. And the system also allows them to do that and to map that achievement against the resources. So here's data management. This is a data management environment as opposed to a searching environment. So how does it work? How does it work? It has basically three processes that we go through in creating the data and preparing it for use. We call it atomize, describe, and relate. Atomization is the process of data analysis, where we decompose the curriculum document out of which we will derive the learning outcomes. There is the atomization process, the decomposition. Once we have decomposed it into semantic units, individual semantic units, those semantic units are described, fully described, and assigned a unique identifier so that they can be retrieved. And then finally, relating is the process, the rich process by which all of the things that were decomposed into individual components can be put back together in different forms, forming different curricular structures, portfolio structures, learning path structures. All of that is part of the relate. So we atomize, we break apart, we describe, and then we give the capacity to put it back together in rich forms. So atomization is the process where the data analyst takes the work of the curriculum designer and extracts semantic units. They have certain, at least in the ASN and best practices within the framework, certain things they have to do. They have to be loyal to the text. The data analyst is not the curriculum designer. The data analyst must be loyal to the curriculum designer. So they must be loyal to the text and accurately represent the text as data. Loyal to granularity. Sometimes the standards are expressed at a level that is not quite as granular as it might be, but that was a choice of the curriculum designer, and the analyst does not meddle with that choice. It expresses it at the level of that is given to them by the designer. And the last one is that this process of atomization is the breaking down of a narrative, a rich narrative, into data. So it's moving from a narrative representation to a data representation. So it's breaking out the semantic units, being loyal to the text, not exercising inappropriate levels of discretion in expressing it anything differently than the original, and then recognizing that they are representing data, that the role here is for machines to be able to manage this representation. So it's not the original, it's data that has been derived from the original. And here we see this process in action. Here is the benchmarks for science literacy from AAAS, the American Association for the Advancement of Science. 418 pages of extremely rich narrative, rich curricular descriptions embodied in the benchmarks. In general, when we extract the learning outcomes, they are hierarchical, and these will look very, very familiar in terms of structure. They look like the national curriculum from most places. The learning outcomes, the core objectives, whatever they're called, have this structure. They are hierarchical generally. Anyway, we extract by pulling out each of these individual semantic units. So we go from narrative to data. We have two different people working at this. There are the curriculum designers who create the rich narrative, the canonical version that we always link back to, that we always reference, and then the data designer whose role is to loyally create a data representation of those semantic units derived from the benchmarks. And here you can see some of them that we've pulled out. Very, very important that this relationship between the narrative and data is a symbiotic relationship. And I've tried to indicate that in terms of loyalty to text and the derivation of data. That the data that is derived from the narrative needs to feed back to the creators of the narrative, so that there is this relationship of alignment that brings harmony into the representation of the data, of representation of the narrative by the data. Describing. Once these atoms, these semantic units have been extracted, they are richly described. And I won't go into great detail. You can look at the rest of the text here on the cells, on the handout. But the function here is to describe each of those semantic units, each of the nodes that have been pulled out of that document in a rich manner. And we saw when we looked at the Common Core State Standards, and we looked at that one statement, we saw how rich the data was. And here we see an illustration of that with something from the AAAS. Planets change their positions against the background of stars. That's the little piece of text that is the achievement standard. Then over here we see all of the various descriptive aspects. At the top, we see the unique identifier that has been assigned to this node, to this specific standard, and then down at the bottom we see is part of, and that is what links this node back to the benchmarks document itself. The rich description has many, many properties. Here we see 3 columns over on the far left. Descriptive properties. These are the property. All of these properties can be used to describe an individual achievement statement. On the far right, we have administrative metadata to describe actions, basically against that pertain to that achievement standard. And then in the middle, we have a list of what are called mapping predicates, or the relationships. These are those things that connect one node to another, one achievement standard to another. A fairly rich array of properties to describe these achievement standards. The ones in red here are all controlled vocabularies. In other words, they are vocabularies where very precise terminology has been used. Most of those terms are also assigned URIs so that they too can be linked to. And a few of them here, we see the ASN US. These are US. ASN US subject topics. These are the curricular topics in the US. And we see US education levels, so that we can uniquely identify a node as pertaining to grade 4 or pertaining to undergraduate, lower division, or postgraduate. So these vocabularies are machine encoded so that they can be assigned to these descriptions and provide us with relationships between resources based on these characteristics as well. Then comes the exciting part. We have analyzed, we've broken apart, we've described. Now we want to look at putting things back together in useful ways. We call this creating achievement maps. Achievement maps is a category. It's the class of maps or graphs that define relationships between these individual nodes. So a given set of achievement standards that have now been broken apart and described can have 1 to n achievement maps. They can have many of them created by 1 to n organizations and individuals, teachers, students. Achievement maps are all exist. They're called by different things. I think in the Netherlands here you have a thing called learning trajectories. Those are for us achievement maps. You'll see in the U.S. There are things like this, like strand maps. The AAAS, with their benchmarks for science literacy, create strand maps or pathways through this data. So curricular structures are achievement maps. Curricular structures are achievement maps. They can also be used for student portfolios. In other words, when you say that a student went from this achievement standard to that achievement standard to that achievement standard to that achievement standard, you create an achievement map that has a direct relationship to a student portfolio. And then, of course, achievement maps can be derived from the contexts. For example, you may have two publishers publishing textbooks dealing with the same set of achievement standards. Excuse me, I kind of bounced myself ahead here. Dealing with the same achievement standards and have very different achievement maps, different methods. In other words, I think methods is a term used here in the Netherlands. Different methods, and you can capture those with achievement maps. So achievement maps are this category. Now, achievement maps are what take the atoms, those individual things that we pulled out, and begin to put them back together in useful forms. So an set of achievement standards, as illustrated in the bottom here, can have multiple maps layered on top of it for different purposes. Some may denote selection and sequence, selection of which achievement standards will be used, what is this sequence, and so forth, taking various forms. The AAAS creates what they call strand maps. So they take those hierarchical expressions of the benchmarks for science literacy, which look like standards documents or curriculum documents from most countries, and they take those hierarchies and they blow them apart and they put them back together in strand maps, what they call strand maps. These might be trajectories, learning trajectories here in the Netherlands, but I'm not sure. Not sure whether those would be exactly the same. But it's the putting back together in useful ways. So an set of achievement standards, the marbles here at the bottom, may have different maps structured on top of it. And this could be 1 to n different maps. So achievement maps are the way you bring meaning and curricular structures into being in the ASM. And of course, nothing says that they can't be cross-jurisdictional. Doesn't have to, all the marbles don't have to come from the same set. They don't have to come from the same national curriculum. You may mix. We find this to be really the case when we have students in the U.S. who, being a relatively mobile society, who move from state to state, and each state has different standards. So this might be a student portfolio mapping from across those various states and those various state standards. The standards can also be enriched if we were to take what we see here in the middle as the AAAS, for example, strand benchmarks for science literacy. Some of those nodes, the blue nodes here, may not be quite granular enough to meet the needs of, say, a publisher that is creating assessment instruments. The framework can be used for those publishers, here Publisher A in a closed system and Publisher B in an open system, to create their own descriptions that further decompose each of, as we see here, nodes in the original curriculum, to create their own proprietary nodes for use in creating textbooks and so forth. So it's an extensible model. And we see here an example from Pearson of doing exactly that. On the left, we have an Illinois Learning Standards Stage F for social science, 3 statements from the original. And on the right, we see Pearson's derived statements. They needed it more granular. So they create their own nodes using using an ASN framework, they create their own individual nodes that are then tied back to the original. There are many kinds of mapping relationships, and I will only briefly touch on them here. They are in a growing class. In other words, what are the kinds of relationships that make up these mapping structures? We identify 4 categories: requisite, identity, structural, and associative. And there may be more waiting, as we say, in the wings. The requisites are properties that define logical sequencing, so that you may have two academic two achievement standards, one that is an antecedent to the other and one that is subsequent to the other. So you get this in prerequisite structures and so forth. There may be some that are coincident, have to be done at the same time. Those kinds of relationships can be expressed using requisite mapping properties. Identity. Sometimes you'll have nodes that are close. For example, you might have a node in a curriculum in the Netherlands and one in the UK, and you might want to designate that there is a close match between the two. So resources that have been mapped might be used. So identity denotes how close a match there is between two nodes. Structural relationships, we need to rebuild the hierarchies that things came out of, so we have broader and narrower and is part of. These structural relationships provide the means of putting back together the documents that we decomposed. And then associative relationships, and I again bring up the AAAS strand maps. And here the strand map is richly developed. If you look at from the bottom of the strand map to the top, you are progressing through time as the student moves across education levels. And from right to left, you have different topical areas. So these are the logical mappings, and these are the associative mappings. This is the area of greatest growth, where we're learning the most as we play with this data in real environments. So that's it. Here's a list of resources. If you want to go look at the ASN data store, please do. It's the second link up from the bottom. So thank you very much.